I'm going to talk about something that doesn't fit into where we are technically in the class, but is important to talk about today because today is September 11th. I know most of you were probably either not born or were 1 or 2 years old when September 11th, 2001 happened. So relate to it in a very different way than people that are older do. I was already a professor at UVA. It was about my second year here when it happened. It's definitely something that you're all affected by, even though you weren't alive when it happened, and we're still at war in Afghanistan, and a lot of things about our country changed in ways that we're still recovering from or suffering from. I'm not going to talk about politics more, but I want to talk about one of the people who was killed on September 11th, and actually by many accounts the first victim on September 11th. This is what Charlottesville looked like shortly after. We're going to do a little history lesson of what the internet was like, because I know you were not using the internet 20 years ago. But this is kind of what it was like. There were clients running browsers. They were probably running Internet Explorer from Microsoft. And they were sending packets through routers. And they were going to sites. And the biggest site on the internet in 1998 was Yahoo. You might wonder, why weren't people using Google? Well, this is what Google looked like in 1998. It was starting to exist, but not the place that you were going to do your regular searches at. So with that architecture, there were evil people around, which I guess we know there are lots of types of evil people. There were ones that were trying to launch attacks on the internet. And the kind of attack they were doing was, at this time, all you really needed was a few nodes on the internet, and you could blast traffic towards the site. And if you blasted it with traffic fast enough, it would bring the site down. If you crafted your traffic a little more carefully, you could bring it down more quickly. If you had malware and you could compromise a few thousand Windows machines and direct them to also blast traffic at it, then you could really cause havoc. And this was causing pretty serious problems. They would do this basically to blackmail the company. They would direct all their traffic at Yahoo, and then they would send Yahoo a blackmail notice and say, pay us $1 million if you want us to stop doing this. And Yahoo didn't have a very good solution to it. The obvious solution to this is, well, we should make it so the clients who aren't trying to bring down the site can still get the content. Caches do this. If we're going to have the content we're looking for stored other places, well then, even if the attacker has some path to send a lot of traffic to Yahoo and can flood that path, if most of the clients are getting their content through some other location, directing it to a cache that has the content, then we're okay. But there's a big problem. The clients have to know where to go. They know yahoo.com, they can look up Yahoo's IP address, but they don't know where the cache is. I think you have probably all seen hash tables in some form. You definitely use them. Hash tables give us a way to do a lookup with constant effort. We don't have to search a table, we don't have to do any complex decisions. We have some function that, based on the key, which could be the name we're looking for, and knowing the size of the hash table tells us where to look. And we would only have to look in one place and get the place we're looking for. And if everyone had all that information, it would be easy to find the cache. The problem is, if you're talking about making this work on the internet, well, some of the nodes go down sometimes. New nodes come up, there's uncertainty. You can't assume everyone has all the same information and knows where to look. So what you need is something that allows you to find things even without this kind of agreement. And the idea to do that is to make it so, instead of having some fixed kind of hash, what we have is hashing that, even with uncertainty, is going to get us close to the right answer. So this is what's called consistent hashing. The key idea is, instead of having a flat table, like you think of a regular hash function having, we're going to put things in a circle. We're going to hash from any key is going to hash to some point on the circle. And then we're going to look from there for nodes. And if we don't find it, or we don't know of a node right where we're looking, well, we can follow the nodes around the circle, and they can be structured kind of a tree that you're walking up that tree until you find what you're looking for. This is what this paper is about. This was published in 1997. One of the authors is Daniel Lewin, who was the first victim of September 11th. The way theory papers work, authors are listed alphabetically, so he was actually the one who was really the lead of this work, even though he's not listed first. The other author you might recognize, Tom Leighton, is one of the authors of the book a few of you used in discrete math, but we've cited a few times and linked to in this course. Everything in that paper are things that by the end of this class you would be able to understand. It's not the easiest paper to understand, but doesn't use any more fancy math than you already know and that we'll see in this class. Like I mentioned in the second class, starting with the right definitions is really the essential part of this. There are some trickier theorems to prove in deciding the right protocols to make this work, but it really all follows from having the right definition. This led to a company. So how many of you have used Akamai? How many of you use Twitter? So your images came from Akamai? A lot of sites now build their own systems like what Akamai built. So Facebook has its own CDN instead of contracting with Akamai. But they deliver a good chunk of the traffic, especially images and JavaScript, CSS files that are reused across a lot of sites by caching it and delivering it. And part of that is having a real good view of what's going on the internet. And they can see a lot of traffic because they do have these caches spread out all over the world. Daniel Lewin was the co-founder with Tom Leighton and a couple other people of Akamai based on this idea of doing distributed hashing. He was on the plane that left Boston on September 11th. By many accounts, he was the only one on the plane that tried to stand up to the terrorists, and he got stabbed. And then they flew into the World Trade Center. This is the recognition that I hope he gets. I've posted a link to a couple articles that I hope you'll at least read the first one. And the other thing I would encourage you to do, since you were not old enough to be aware, if you haven't talked to your parents about September 11th, it would be a good idea to do that sometime.